The discovery. 3I Atlas entered our sky without spectacle. No bright plume, no sweeping tail, no warning. Just a pale, irregular blur captured on July 1st, 2025 by an Atlas survey telescope in Chile. One faint point among thousands, the kind astronomers almost disregard as noise. But faint objects have a secret. They betray themselves through motion. On the following night, the point had shifted. Not by much, yet enough to rule out coincidence. Another night passed, and the movement became undeniable. Too fast for a solar system comet, too straight for an asteroid, and far too unbound for anything native to our sun's influence. What they were seeing was a trajectory stretched nearly to infinity, a hyperbolic path, the unmistakable signature of an interstellar visitor. The alert spread quickly across observatories. Hubble was retargeted. The James Webb Telescope warmed its instruments. Ground arrays aligned. Even distant spacecraft, among them China's Tianwen-1 orbiter, pivoted their cameras outward to capture the fleeting chance. Within hours, the object earned its designation. 3I Atlas, the third confirmed interstellar object in human history. Its speed was extraordinary, over 58 kilometers per second relative to the Sun. Too fast to capture, too fast to curve into orbit. It would pass through our solar system only once, like a stone skipping across a dark ocean. And yet, despite its rarity, almost no one on Earth would ever see it. To human eyes, it remained invisible, too dim, too distant. But to the instruments studying it, 3I Atlas was a frozen survivor older than the planets beneath our feet. Imagine yourself floating beside it in silence. No wind, no rumble, only the depthless cold of interstellar night pressing against your suit. The object drifts past you like a shard of obsidian ice, dark, pitted, ancient. The sunlight feels thin, as if even light hesitates to touch a body that has wandered the galaxy for billions of years. It carried no message, no intention, no warning. But it carried a story, one written long before Earth existed. And that story began revealing itself in its age, a visitor from before our time. Tracing the orbit backward through the galaxy produced a number that almost defied belief. Somewhere between 7 and 11 billion years of travel. Longer than Earth has existed. Longer than the sun has burned. Longer than life has been possible in our oceans. 3I Atlas belongs to a chapter of cosmic history older than our world by half the age of the galaxy itself. Whatever star system birthed it may be gone, its sun extinguished, its planets shattered or swallowed, its dust dispersed among the spirals of the Milky Way. During its unimaginable journey, the comet endured everything the cosmos could throw at it. Cosmic rays pierced its body, breaking molecules apart. Micrometeorites scarred its surface. Stellar winds stripped away layers of ice. Temperature extremes reshaped its crust over and over again. What we now observe is not merely an icy remnant, but a scarred survivor, weathered far beyond anything found in the Oort cloud or Kuiper belt. Its closest pass to Earth on December 19, 2025, placed it 167 million miles away. Safely distant, yet close enough for modern instruments to capture a flood of data. Each observation added to a portrait of an object older than Earth's continents and the first cells that lived upon them. Imagine drifting near it again, but this time noticing the thin whisper of gas lifting off its surface. Ancient ices, vaporizing for the first time since before our sun ignited. The jets rise slowly, lazily, as if awakening from geological sleep. They sparkle faintly in sunlight before dissolving back into blackness. In that moment, the sense of time becomes overwhelming. This object was frozen solid before Earth existed, before the moon formed, before our solar system even coalesced out of dust. It is a relic not from another world, but from another age. An age when the galaxy itself was young and full of fire. And yet, despite its great age, its chemistry revealed something even more startling. 3I Atlas was not just old. It was alien, built from materials unfamiliar to any comet formed around our sun. The next section would expose those materials and the strange clues they carried about the comet's birthplace, the anatomy of an interstellar comet. When sunlight finally touched 3I Atlas, the comet reacted like something remembering warmth after billions of frozen years. Thin vapors seeped from fractures near its surface, and in those fleeting gases, astronomers found the first true window into what the object was made of. The James Webb Space Telescope captured the chemistry with remarkable detail. Its instruments analyzed the faint light passing through the comet's newly formed coma, the fragile atmosphere of gas surrounding its nucleus. Embedded in that light were signatures of the building blocks inside the comet's ice. Hydroxyl appeared first, the broken remnants of water molecules torn apart by solar radiation. Carbon monoxide followed, a common volatile in cold, distant comets. But then Webb revealed a surprise: carbon dioxide, in quantities far exceeding anything seen in the comets of our own solar system. In our cosmic neighborhood, CO2 is present but modest. Many solar system comets carry only small traces of it. But 3I Atlas released it in abundance, suggesting a birthplace radically different from the cold regions where our own comets formed. It hinted at a star with a different radiation spectrum, a colder disk of dust, or a chemical environment that simply doesn't exist here. And yet, as striking as the chemistry seemed, it only told half the truth. Because the surface of 3I Atlas wasn't pristine, it was altered by time. Billions of years of cosmic radiation had bombarded the comet, penetrating meters deep. This radiation breaks molecular bonds, reshapes chemical structures, and turns the outer shell into something fundamentally different from the untouched material buried beneath. Scientists called this outer shell a cooked crust, not burned by heat, but baked by cosmic violence. It meant the gases escaping now might not reflect the comet's original composition at all. The CO2 could be a chemical echo created by radiation damage. The hydroxyl could be the product of surface ice broken and reformed countless times. Even the dust rising from the comet might be chemically distinct from what lies deeper within. Picture reaching out to touch that surface. It would be fragile and brittle, like dark pumice left too long in the cold. A gentle press would send grains drifting away silently, each one older than any mineral on Earth. Beneath your fingertips, the crust would feel layered, stratified memories of its long interstellar voyage. As sunlight warmed it, fractures opened, gas rose, dust lifted, the coma thickened. To telescopes, it looked like a ghostly halo surrounding a shadow, but the activity was only beginning. The deeper 3I Atlas moved into the inner solar system, the stranger its behavior became, and that strangeness would capture the attention of astronomers around the world. A comet's puzzling behavior. By late 2025, something unusual happened. 3I Atlas didn't just brighten, it accelerated. Its path shifted in a way that no gravity model could fully explain. Most comets experience non-gravitational acceleration. As their ices warm, Jets of vapor erupt from vents and fractures, pushing the nucleus like tiny thrusters. Over millions of kilometers, even a gentle puff of gas can alter a comet's course. But with 3I Atlas, every detail mattered. This wasn't a familiar comet that astronomers had studied for decades. It was a visitor from another star. So every deviation felt like a clue. The acceleration suggested one thing clearly. 3I Atlas was actively shedding material. The jets weren't violent. They were subtle, intermittent, and often invisible from certain angles. Dust drifted behind it like pale smoke. Gas escaped in pulses, rising from deep cracks where ancient ices finally met the warmth of a new sun. Some telescopes caught only a faint coma and little else. But then Tianwen-1, orbiting Mars, sent back a sharper image. A distinct, luminous cloud of dust surrounding the nucleus. Not dramatic, but unmistakably real. If you were drifting alongside the comet at that moment, you wouldn't feel the jets. They'd be too weak to disturb your suit. But you would see them. Shimmering filaments of vapor unfurling into the void, illuminated by sunlight in thin, delicate ribbons. Each plume carried particles older than Earth's crust, drifting outward like lost memories returning to space. As the comet approached perihelion, the activity fluctuated. It brightened suddenly, then dimmed. Its trajectory wavered almost imperceptibly. Some jets seemed to erupt in asymmetric bursts, giving the comet a faint rotational jitter. These changes were natural for a body warming for the first time in billions of years. Yet, even ordinary behavior becomes compelling when the object is interstellar. Every flare, every shift, every sudden glint of dust sparked debate. Was the acceleration stronger than expected? Were the jets too subtle to explain the motion? Was the coma too faint for the amount of material the models required? Questions multiplied faster than answers. Most explanations pointed toward simple physics, non-uniform venting, unusual ice chemistry, a surface reshaped by radiation into unpredictable pockets of gas. But one question began circling through the scientific community and the public alike. Why did this interstellar visitor behave almost, but not exactly, like a comet? That question would lead, inevitably, to speculation, to theories, to possibility, and to a familiar debate that would flare once again when 3I Atlas passed near Mars and Jupiter in an unusual sequence of alignments. The next section would explore that speculation and the scientist who brought the question into the light, the alien question. Whenever an interstellar object behaves even slightly beyond expectation, imagination accelerates faster than physics. And with 3I Atlas, curiosity ignited quickly. Avi Loeb, known for proposing that Oumuamua might have been artificial, raised the question again, not as a declaration, but as a challenge to scientific complacency. He pointed to three features he considered worth examining. First was the non-gravitational acceleration. To Loeb, the push seemed stronger than what some early coma detections suggested. If jets were producing that shift, he argued, certain observations should have shown a dramatic tail. Some didn't. Second was the trajectory. As 3I Atlas swept past Mars and later approached Jupiter, Loeb noted the sequence resembled a set of opportunistic planetary flybys. In his view, it echoed the pattern a reconnaissance probe might use to map gravitational environments. Third were the initial spectral surprises. Early low-resolution data, later refined, contained hints of unusual metal ratios or unexpected lines. Most teams attributed these to noise, but Loeb argued they should prompt investigation, not dismissal. His argument was not that 3I Atlas is a probe. His point was philosophical. Rare events deserve open-minded analysis. History, he often says, is shaped by outliers, black swans that reveal new truths when they're examined carefully rather than ignored. Standing beside the comet in your mind, you can feel the tension of that possibility. Run your gloved fingers across its cracked surface. Imagine ancient technologies hidden beneath eons of dust. Imagine purpose embedded in something that looks like a frozen stone. But imagination must eventually yield to evidence. And the evidence pointed in another direction. The message of 3I Atlas. Now 3I Atlas is drifting away from us again. Its coma thinning, its vents cooling, its surface returning to darkness. Soon, it will slip beyond the reach of every telescope we have, becoming once more what it was before we found it. A silent, ancient body wandering the galaxy alone. But it leaves behind something irreplaceable. Perspective. 3I Atlas is older than Earth's continents, older than the oceans, older than life. It carries the chemical memory of a world that existed long before ours, a world that may no longer exist at all. Picture its origin: a young star brightening for the first time, a swirling disk of dust and ice, fragments colliding, merging, shattering. And in that chaos, a small, icy shard is thrown outward with such violence that it never returns. It leaves its star behind, pushed into the deep cold between suns. For billions of years it drifts, unchanged except by the slow, relentless hand of cosmic time. And then, by pure chance, it crosses paths with a species capable of noticing it, measuring it, wondering about it. We are the only witnesses in its entire journey. 3. Atlas reminds us that we live in a galaxy filled with lost histories, forgotten systems, and relics older than imagination. It reminds us that Earth is not the measure of the universe, but a temporary sanctuary within it. And as the comet disappears into the dark, it leaves us with a quiet invitation. Keep looking, because every so often, across the vastness of the galaxy, something ancient will wander close enough for us to see and remind us how young we truly are.